Alright, let's dive into the wild side of factorials. You know factorials, right? That exclamation mark after a number like 5 means you multiply all whole numbers from 5 down to 1. So 5 is 5x, 4x, 3x, 2x, 1. Easy. But lurking just beyond the classic factorial are some quirky relatives. Let's meet 3 subfactorials, primorials, and double factorials. First up, subfactorials. Notation? It's an exclamation mark with a little slashed 0 before it, and or more formally n with a bar over the exclamation mark. Subfactorials count. That's the number of ways to scramble n objects so none end up in their original spot. Imagine n friends each get a secret Santa gift, but nobody can pick their own name. Subfactorials tell you how many ways that can happen. For 4 people, the subfactorial of 4 is 9, so there are 9 possible perfect mess-ups. The formula? It's a bit wild. N equals sign nx. 1 over 1, plus 1/2, 1/3, plus, minus 1, circumflex, n. Next, primorials. Notation, n hash, that's a hashtag, not a factorial this time. Primorials work like factorials but only multiply prime numbers. For example, 5 hash means 2x 3 times 5 equals 30. See what I did? I skipped all the non-primes. Primorials pop up in number theory, especially when exploring primes in cryptography, primes gaps, and even the Goldbach conjecture. They grow fast, but not quite as explosively as factorials. On to double factorials, written n in double exclamation mark, in. Here's the deal. You multiply numbers counting down by 2s, not 1s. So, 7 is 7x 5x 3 times 1 equals 105. If you start with an even number, let's say 8, it's 8x6, x 4 times 2 equals 384. Double factorials are huge in combinatorics and physics, especially with odd and even arrangements, and when calculating volumes in high-dimensional spheres. Let's recap with a quick visual. Factorial, multiply everything down to 1. Subfactorial count derangements, the art of perfect chaos. Primorial, multiply just the primes. Double factorial, skip step, multiplying by 2s. These aren't just mathematical oddities. Subfactorials matter when you want to avoid matches. Primorials reveal prime patterns, and double factorials unleash symmetry in physics. So, next time you see a number with an exclamation mark, look closer. It might be one of these fascinating cousins lurking in the shadows. Happy puzzling!